Hey everyone, how are we doing? It is Wednesday morning. Oh my gosh, one full week of school left. That's all we have. And I just can't believe it. Hannah, good to see you here. Let's see, let's load up some of those assignments. I think we got everything good to go over here. We got PowerPoints, we got so many things. We got the chat going. If you're in the chat right now, say hey, and we can start doing some assignments. Let's see right here. Who's in the chat? I know we have one person. Hey, Leslie, good to see you. Which assignments are you working on? Let's see, are people going to be wondering about chapter 17? That might be the topic du jour. We'll find out. Whatever people want to work on, we can start talking about, we can start working on. Got so many things. Let's see here. Project 2 grading. I'm looking over all the... there's so many things. Let's see here. There we go. What questions do people have right now? Chapter 17, you bet. Leslie, which one do you want to do? Chapter 17 homework. Should we do the homework first? We haven't done the homework lately. Let me get the homework. Hannah says chapter 17 homework. You bet. If that's a single, like, what is it? Full House for like, you got it, dude. And Full House. I miss some 90s. You know, like then when we just start missing like the early 2000s. That's what people probably miss nowadays. They're like, oh, I miss the early 2000s. I'm like, oh, that's like when I was in college. I'm old. Anyways, okay, let's do the homework. Here we go. I got it up and going. Let's do this. Enough reminiscing with Brian. Okay. So here we are. A study examined the fat content for samples of beef in meat hot dogs. The resulting 95% cholesterol goes from blank to blank. Complete parts. So what is this doing right here? So you have to think about like visually. Let me make sure right here. Let me make sure class is over. Good. 2 seconds. Okay, there we go. And okay. So what we're doing right here is we're just taking different hot dogs and we're measuring the content of fat in them. And we're going here and we're saying, okay, like we have fat from like 8 grams of fat to like 20 grams of fat. And we have here the beef and we have here the meat. For some reason, they're marketed that way. Can we do this next command? Yeah, Belly, we'll do that one next. You got it. So here's what we have going on. This is the data. And this is what we're noticing. What are we going to get for both of these right here? For both of these, we would get what's. It might be out. It wouldn't be outliers technically. For both of these distributions, we're going to analyze the what's for them. For both of these distributions, we would analyze the what between the two groups. It might be somewhere around here and somewhere around here. And we're going to look at the what between these two distributions, which this one's way bigger than it is. But we're trying to analyze the difference between the what's. What are we trying to analyze right here? I guess we should put this. What are we trying to analyze here? We're trying to analyze the what between these two groups. So I've drawn it out visually right here. Like what we do, like how you would do this is you would take a hot dog, you'd figure out how much fat it has in it in grams. So you would go here and you'd be like, okay, how much fat are in these hot dogs? So you'd be like, how much fat are in these hot dogs? And then you would measure and you'd be like, okay, this hot dog has 20 grams of fat. This hot dog has 14 grams of fat. This hot dog has 10 grams of fat. We're analyzing the means, correct, and then we're analyzing the what between the means. So we're analyzing the mean for this group, which is right here. There's the mean for that group. And we're analyzing the mean for this group over here. I can't go grab it, but the mean for this group right here. And we're analyzing the what between the means. We're trying to analyze the what between the means. You are correct, Hannah. That's the whole point of this chapter, is to take two groups, look at their means, and then analyze the what between the means. So you can literally see it mathematically here as we talk about it. We're analyzing the what between the means of the two groups. So that's what it looks like visually. It's like, okay, we're taking samples of beef hot dogs, we're taking samples of meat hot dogs. No, you're totally right, Hannah. You're on the right track. Let's throw out some 100 points right here. Mubot, are you awake? Mubot, we got to re-wake you up. Let's re-wake up Mubot. He'll crash the world, but that's okay. He's the world crasher, Mubot. The difference, right, Leslie? Mubot has brought back our world. So we're trying to analyze the difference between the means. And when we look at this right here, I think I might have done it properly. It says beef minus meat. And if you look at this, which I think I've drawn out properly, No, it's beef minus meat. So let's change this. Okay. So when you look at this, meat is higher than beef. This is the way their problem works. So when we analyze this difference right here, we notice a positive difference. The positive difference we see at first right here is negative 2.7. So what we're saying is the mean for this one might be as much as 2.7 higher because we're doing mu beef minus mu meat. So this one could be somewhere as much as 2.7 higher, or this one down here could be as much as, let's see the number on it, wrong thing, could be as much as 0.8 higher. Because there's uncertainty. I might not have drawn it perfectly today to like show that the difference right here is uncertain. And you might be like, well, wait a minute, beef is lower. But it could just be random variation. If I'm to do this more accurately, I might be able to get all the dots right there. Can I get all? I can't get all the dots. If I were to do it more accurately, they would be a little bit closer to each other. And we would say that this difference is uncertain. Like it could be as that beef is as much as this much higher, or it could be as much as, I wish I had just done it a little more accurately today. Might be able to move everything. There we go. Look at that. Look at that. Much better. Much better. Looking more like it should look. There we go. There's the mean. There's where the mean is at. We're trying to analyze the difference between these means, which is what we're analyzing here. Now that looks more accurate. That looks like a more accurate, like, the difference is right here. It could be that, we think probably that maybe meat hot dogs are as much as 2.7 higher because the negative difference right here would denote the second one's higher. Or it could be that beef is higher. So these differences right here, the true difference between these could be what? What number do you notice is between these two numbers? Like going from negative to positive, what is between these two numbers is 0. So there might be no difference between these. The differences between beef and meat hot dogs and the amount of fat we see might just be due to random chance. And even more so, it probably should look even closer because I'm just trying to make it visually look like, yeah, that looks good there. This right here is probably about how it should look if we're going to graph it out. If you were to look at this, you might be like, okay, we observe that meat is higher, but beef was a little bit lower. And these are not the means. These are the differences where we think that beef might be as much as 0.8 higher, or meat might be as, hey, good to see you here, Kayla. Hopefully this drawing is making sense to people. I always try to do visualizations of what we're talking about. And I hope this visualization makes sense that we're trying to analyze the difference. And the difference right here is actually rather small. And it could be that meat hot dogs are as much as 2.7 higher, or it could be that beef hot dogs are as much as 0.8 higher. So, oh shoot, I got to release that. Oh my gosh. Sorry, Kayla. I was working on something big last night. Statue 1 cheating stuff, and let's just say that took like 2-3 hours, and that's not a good thing. Please, if I email you. I should have that release later tonight. I'm so sorry, Kayla. I'm so sorry on the delay on that. Yeah, no, I will. I said I'd release it yesterday, and then I went to sleep, and I'll release that tonight. I'm so sorry. End of semester. Why end of semester? I know. No, it's it's not good. I hate it. I hate dealing with it. I just hate it. It's the worst part of the semester, anything like that. The endpoints of the confidence interval have opposite signs. What does this indicate? So when this number here is negative, this is very important right here. This means that meat might be higher. When this number is positive, it's so much effort to like go through and to like, for me to like find it and determine it and make sure we have enough evidence. It's a lot of work. Like I put a lot of work into making sure the hot dog with a higher mean for fat cannot be determined. I'll show this right here. Let me explain. What does the fact that it contains 0 indicate? The difference, it's insignificant. This means the difference in two samples is insignificant. And if we use this to make a confidence roll, so we'll project grades, they should be in by Friday. They should be in. The graders have been told that. And so we got to hope, Bailey, got to hope. Project, people have been getting them in. And 95% confidence relates to a 0.05. And I'm going to show some important stuff right here. "95% confidence relates to a two-tailed alpha, where the alpha level is what? What is the alpha level equal to for this? What would the alpha... How can you tell if distribution is nearly normal when comparing two means? We can make histograms. We can make a QQ plot. We can look at histograms, QQ plots. We can look at goodness fit test, or we could use the large enough n condition. Those are the 4 ways right there. So you look at the histograms maybe and see if they look nearly normal. So also, if you have a large enough sample size, I think you might be talking about the project or the visualization. So if you have a large enough sample size, as long as they look kind of normal, you're good, like the large enough n condition. And so what would what would the alpha level be for this? Using a 95% confidence interval, great job, Maggie. Using a 95% confidence interval, what would the alpha level be? Oh, and Kayla, I got it approved. The bonus stuff, the tentative bonus, totally approved. I'll be announcing that in class, but the tentative bonus I announced with 320, I got totally approved. 201 got some bonus points on their exam. 320, we worked on another bonus. As long as it's not heavily skewed. You could mention that it's not heavily skewed or something like that. As long as when you look at it, I might go actually download that data set. Here, I'll answer that one next, Maggie. So I'll go like directly answering that. Yeah, I know, right? So what is the alpha level for this two-tailed test going to be? What is the alpha level for this two-tailed test going to be? So we have 95% confidence. So the confidence interval, and then what is the alpha level? And then Bailey's got another one we're going to do. I'm going to answer Maggie's question real quick. What would be the alpha level? So this is a two-tailed test. You're welcome, Maggie. What would the alpha level be for the two-tailed test? Any ideas what this alpha rejection rate would be? So it's basically just like a 95% confidence interval, but we just do, instead of the inside, we do the outside. So 95% confidence intervals are relative to a two-tailed test. The results that we get are similar, or they'll follow in line with a two-tailed test with a certain alpha level. And what do? Just do 1 minus confidence level. So the confidence level for the two-tailed test right here is going to be 1 minus, or not the confidence level, the alpha level for the two-tailed test. We just go right here and it's a 5% alpha. It's not 0.05% alpha, it's 5% alpha or 0.05 alpha. The alpha is out of 100%. So it's 5%, or there we go there. We'll come back. We'll do more of this here in a moment. We're going to answer Maggie's question. So Maggie had a question. Then we're going to do the driving to work question right here Bailey had. So Bailey, and I think it's just, this one is quicker. Let me get the actual data set right here. So I'm actually going to go get the actual data set. We'll look at it really briefly right here. Oh, I've had my 2 cups of coffee. I've had my 2 cups, and I'm still tired. I need my awake chocolate. 2 cups of coffee and an awake chocolate. That's, my gosh, we've done so much work this semester. Thank you, everyone, for all the hard work. And I talk about the problems with cheating, but in truth, the amount of cheating is relatively low to when you think about how many students we have. So we have a rather large amount of students, and like 10 or so cases of cheating is not ridiculous. Okay, here we go. We got the finish time. A little bit. Here, let's open it up. Maggie, let's hop over here. And there we go. Awesome, Bailey. You got it. We're going to do that next here after this one. So let's do it. And thank you so much. Everyone's always so polite in here. Like, everyone's like, I'll wait. And like, you got a moment. So I appreciate that so much. No one's ever been like, got more question. Okay. Here we are with the data set. This is the actual data set. So we are taking a sample of 35, right? Please correct me if I'm wrong. We're going to go here to subset. We're going to go to 35. We're going to hit enter. There we go. Sample of 35 obtained. So I should see similar-esque results. I'm not going to interpret too much here, but you're going to see some very similar work. Sometimes I do something kind of directly related. So we're going to go to analyze fit y by x. I was doing stuff like this yesterday. I would go into more detail yesterday. So if you're watching this video right now, I'm not really going to interpret these results. I don't mind showing you the jump work because we're not trying to make you experts in jump. Like, that's not the goal of this class, to make you a jump expert. We're trying to make you understand how to interpret results. So I don't want to interpret these results because that's your job. I want to just show you that's how you create it. We put gender into the fit y by x down in the x variable. That's the explanatory variable. And finish time is what we want to understand, the y variable. So you should obtain something like this. We can see differences right here in the times. What you could do, what should be acceptable. I didn't do this yesterday. You want to go to t-test. We're going to do the 2-sample t-test. There's the results down here. And this is very much like the hot dog problem we just did moments ago. So check that out. So you can see the difference between the means right here, and we're comparing male minus female. So since the difference is negative, which mean would be higher? If you ever want to see the means, do not include this. Do not include this. This is not the test we are doing. Do not include this. Wait, I've never clicked that button. Oh, why not? You can include that. There's the actual means right there to give you a little more information. You might not get that on the test, but you can include that. I was going to do a different test that actually gives you that same info. But wouldn't be the end of the world. This is not required, but you can actually see the means for females and check it out. The mean for female is higher than the means for males, and this difference right here is calculated when you do male minus female mean, and that's the difference we are seeing right here. So hopefully that adds some context to what you're seeing. You're meant to then talk about this and talk about the confidence interval for the difference. That's part of your assignment. And Maggie was wondering about the conditions. Now, one other thing we can add, there should be another button right here. There we go. Okay. There's gonna be some interesting grading. Okay. Button that you didn't know existed. So these distributions are left skew or right skew. Now watch out. Doesn't meet the nearly normal condition. I should talk to Terry about this. Doesn't meet the nearly normal condition. What do you think, Maggie? What would you say with all this information right here? Does it? Because we didn't really talk. This is more about like, let's do a little talk on the conditions right here. Condition 1, random. Okay, these have to, we did randomly select them, so they're randomly selected. Condition 2, 10%. Did we take less than 10% of the finishers? What's the sample size on it? Yeah, we took less than 10%. This is less than 10% of all finishers. So if this is the population right here, we took less than 10%. Does that make sense? So we took less than 10% of all finishers. So we meet the random, we meet the 10%. It does, and then we get to condition 3. We need the nearly normal condition to be met for it to be nearly normal. And this is really top tier. This is A+ output. You can get a 10 out of 10 without making this output. And so Maggie's right. This looks skewed to me. The female distribution looks more skewed than the male distribution, probably because of these 2 observations up here creating the bins. Hey, Dan, good to see you. Dan from last semester, right? Good to see you, Dan. I think so, right? Dan, great. We got Mubot now. He's handing out points. Let me give out some points. Points for Dan showing up right here. If you have any questions, Dan, or just here, say, hey, let me know. So when you look at this, my hair's just keep getting longer, Dan. It's just long hair, Brian. When you look at this, we have skew to the female distribution. I would, and I'm going to talk to Terry about this because he's the one who instructs how to grades. I have the quantile boxes on mine. Can you tell skew from quantile boxes? You can a little bit. It's going to be easier with the histogram maybe. Yeah, you see, you can see the left skew right there. I mean, no, right skew. I got it wrong. Right to the high, left to the low, whatever way the tail goes. It's to the high side. I literally just, I don't know why my brain said the wrong number right there. I would say this is a little bit busy of output. I might not include the quantiles. But I might, this is like for a stats person, this is pretty good output right here. I might not include the quantiles, but you can tell there's a high male outlier right there. The graders should be very nice on this one, in my opinion. And what I might literally email my graders and say they need to show that they understand the nearly normal condition, because in truth, I have my reservations about saying we meet it. It asks for quantiles. Does it say put the, I didn't do the quantiles yesterday. Does it say do the quantiles? I didn't do the quantiles yesterday. Does it say include quantiles in your report? Let me go look at that. Does it say that? Because I didn't do that yesterday. Always read the instructions. Oh, it does say. Thank you, Maggie. We might send an announcement about that. It does say include the quantiles. Oh no, I didn't do that yesterday. So yeah, no, it does say include the quantiles. Maggie, thank you so much. You don't have to include that. So it does say include the quantiles. Great job, everyone, reading the instructions. I kind of go on autopilot sometimes when I complete these things. I don't like missing things, but there we go. This is, to me, I like my output to look really nice. I think right here, this is top tier output. You can see the test really well. You can see the histograms. You can see the quantiles. This is kind of a really good layout when you think about just the structure of it. So if you do something like this, it's just us kind of talking about the assignment. I think this contains all the information to see the skew nature of it, the outlier here. You can see the outlier over here. That's just that one point. So you can see what's going on. And you can see the statistical test. You can see the p-value for the statistical test. And last but not least, so take a big timestamp right here for everything. You need to put this to an alpha level of 0.01. So I went there to set alpha and go to 0.01. And now that changes the confidence interval to a 99%. And you can also kind of see what we would do at the 0.01 alpha level. Yep, I think so. I think we're going to do, is that the bike one? We're going to do the bike trail one after this. But so check out this right here in this video. If you're going to deliver some output for this question, this is the output I would have. So I might even send an announcement like, hey, check out today's video. You're probably watching this right now. This is the top tier output I would have to turn in. It really contains all the information you need related to the quantiles, related to the right test. I would say in truth, this is how statisticians talk. I have my concerns. I have my concerns with saying it's met. And I really think I should, before I forget, let me email Terry. You know what? I'm going to email Terry right now. And Higgins. Okay, 2 seconds. I'm emailing Terry as we speak. Stat 201, visualization 8 for the nearly normal condition. I feel like it is iffy. Whoops. Iffy whether for it being met. Should we grade students on if they give a good answer that shows they understand the condition, but they could go either way? My thoughts. There we go. Okay. There's my email to Terry. I just emailed Terry. It's about cereal. Let's do cereal next. So I just emailed Terry right there, sent him an email telling him I really think we should, like I didn't say it. I literally was telling you what I was emailing him as we were doing this. So my personal view is this is iffy. We could go ahead and do it, but that's the condition I have the most concern about. Does that make sense, Maggie? Please tell me if you think the graders didn't grade you fairly on it. You know, everyone knows I get points back if I disagree with the graders. But I would say I have my concerns about this third condition. They are a bit skewed. I'm not sure if the n is large enough for us to pass the nearly normal condition. So because you want to check it for both. Is this nearly normal? Is this nearly normal? Probably the male distribution is good except for that outlier. If this outlier wasn't here, we'd be probably pretty good on the male distribution. Good to see you here, Roderick. We'll be releasing the assignment later tonight. Sorry about it. I was working on Stat 201, checking for tutors. The female distribution has a little too much of a skew. So the skew in the female distribution has me concerned. The outlier in the male distribution has me concerned. The smaller sample sizes. So I think the best answer is it's iffy. And we can go ahead and do the test, but I have a little bit of a concern. Like I have some concern for this. So I think that's the best answer is I have some concern. It's plausible as my Pearson would say. Okay, let's do the bike trail question. Statistics, as people learn later, or they learn, is not about yes or no answers. It's about what is believable, what is plausible. So we say like, yeah, this seems plausible, seems possible. Okay, we're gonna do the bike trail question, then the serial question. Let's do this. Right, here we go. Here we are with the bike question, not the bike trail question, but the biking question. And this question is all about knowing your equations. So this question is all about knowing your equations. Let's go ahead here and take everything and bring it over to here. And we have right here, a man moves to a new city, sees that there are 2 routes he could take to work. A neighborhood he has lived in, he's got route A, he's got route B. And they tell him this is the claim right here, that the route could be 5 minutes faster. The man decides to take either route. He flips a coin which way he's going to take. 15 days. Route A takes 41 minutes. Route B takes 42 minutes. The standard deviation is 1 for the first for that route. So we need to identify some notation. So start off, who can identify notation on this? This is really good practice. So I've the ones in blue are the ones we should be mainly concerned about right now. So what is, and it says like it passes roughly symmetric with no outliers. It's telling you right there, Maggie, that it passes the nearly normal. It's like, you can go ahead and do this nearly normal. You're fine. So that's where it's telling you nearly normal in this question. So roughly symmetric with no outliers. So this one is roughly symmetric with no outliers. So that's the nearly normal being passed. So what do we have right here? What do we have? What is the notation? This is good practice. What is the notation right here? Anyone know any of the notation? Now, what's interesting, when you do this question, as we try to figure out the notation, which is going to be super important, the way they ask this is route B minus route A, which is something you have to notice right here. They do B minus A. So we're going to set up our equations that way. We're going to do B minus A. So just make sure you're setting it up that way because it's the way they do it. They want a confidence interval for the difference. So when we go to the confidence interval for the difference, the formula will be, and we'll erase this line right here. And we'll keep it. So figure out any of the notation. We need some help on the notation here. What is some of the notation? So we have everything marked right here. So always mark your questions. And then we need to figure out some of the notation. I know which is going to be the hard part. The T is usually the hard part. That's where people usually get stuck. But what is any of the notation right here? What is any of the notation? So y bar B is the mean for route B. Y bar A is the mean for route A. We have here, I'll talk about them, but let's see what people get in the chat. Y bar B is the mean for route B. That's route B mean. Y bar A is the mean for route A. T star is the T relative, I think 95% confidence we're doing. That means relative to the percent confidence. The DF is calculated by the complicated formula. Let me put the applet for the chat. We'll be using that soon right here. We need the applet for the T degrees of freedom. We also need the applet for the T. So MuBot's going to give us both those applets to get the degrees of freedom for the T we'll be using. There's the MuBot applet T degrees of freedom. And then MuBot's also going to put in the chat the T distribution applet, or he should. Come on, MuBot, where's the T applet? He should be putting that there for a moment. And we need to go get the T statistic right there. There's the T applet. We have right here the standard deviation of route B, the sample size for how many times he rode route B, and the standard deviation for route A, and the sample size for route A. So what are some of this notation? I always need help on the notation. So who knows any of the notation here? Who knows any of the notation? Who knows any notation? Do we know what is, now the sample size it gives once, but what is the sample size? Because it says they ride the routes this many times, both routes. So it doesn't say like the sample size for A is this, sample size for B is this. It says both routes were rode this time, this amount of times. So it tells us how many times both routes were rode, which means they're going to do blank samples of this route and blank samples of this route. So what is the sample size for both groups? What is the sample size for both groups? So once we can find out the numbers and we can solve this equation. What was the sample size for both groups? And the idea is we got all the numbers marked up there. Meebot's talking to me. We've got all the numbers marked, and we just got to figure out where they go now. 5 we won't use right now, but we need to know, like, what was the sample size for both groups? What was the standard deviations for both groups? What was the mean for both groups? So this is the goal right here, is to compare the means for both groups, and then to make a confidence interval, here's the margin of error right here. So we know where the margin of error for this is for this interval. Close. So the n wouldn't be 20. The n is going to be 15. Great job right there, Michelle. The n is going to be 15. They rode each route. It might be 20 for yours. It might be 20 for your question. But he rode each route 15 times. So 15 is the sample size. And, oh, that's totally all right. No worries. And then we put the standard deviations right here. It doesn't truthfully matter which order they go in, only because the sample sizes are the same right here. And we're going to add those together, and we'll find out the t here in a moment. There we go. And now we need to go get that t statistic. This is usually where people get stuck, is finding the t. Now, to get the t, we need to go here to the 2-sample t degrees of freedom calculator. And it's up there in the chat where it says the 2-sample t degrees of freedom calculator. And then we put in our sample sizes and our standard deviations, and we go get the degrees of freedom. So now we have to go take the degrees of freedom, and the degrees of freedom tell us which t distribution we are using. So we go over here to this applet, and we look at which t we are using. We're using a t with 17.07 degrees of freedom, and I believe the question said a 95% confidence interval. 95% confidence interval, but that has to be on the right t distribution, and the t statistic is 2.11. 95% inside, 5% outside. So with 5% on the outside, it would be the same thing as 95% inside. Just make sure it looks correct where 95% is on the inside, which could be 5% outside. 2.11 is the t statistic. We've done it. We've written out our equation. Let's go ahead and solve this. 1 times 1 is 1 plus 15 over that. So that's going to be 10 divided by 15, which is 0.66666 times 2.111 is that. Just 1, only 2 ones. And now the difference here is 1, 42. And let's just make sure that is B. That is correct. So the answer to this is going to be 1, because that's what that solves to, plus or minus 1.41. It rounds to that. There we go. We have done it. We have solved for the distribution. Or is that not? So we go right here. We have our margin of error, 1 plus this, 2.41. 1 minus the margin of error, negative 4.1. And I think that's got it. Don't think I made any decimal errors. Oh my gosh, what am I doing? Oh no, I didn't square root it. I knew it. Math error. I did not square root this. Oh, I knew it. I was like, something looks a little small about this. 1 point. Math error. No, I did not square root it. So easy to do. Roger getting all those points. Oh my gosh, I'm going to hit my mug with my elbow because I didn't square root this. So everything should be correct now. Math error, so easy to make. 1 plus this, 2.72. Yes, I was like, Meebot, are you awake? And then 1 minus it. Negative, there we go. So now it should like it, as long as I'm doing all the rounding properly. 2 decimals. Okay, good. I forgot to square root it. Just going a little too quick in my head right there. Easy to make math errors. Carry out all your mathematics. If you're wondering once again what Brian did wrong, Brian forgot to square root once he got through this step right here. I did this, and I did it in my head, and I was like, oh, that's 2/3. And then my brain went right to multiplying to this. I didn't then square root the 2/3. So the math error was right here, I did 2/3, then I multiplied. I should go 2/3, square root the 2/3, multiply. So follow your steps carefully and double check your work. Easy to make a math error. So should we believe the 5-minute claim? Well, the 5-minute claim is outside the interval. So the answer is no. We should not believe that 5-minute claim. The difference seems to be not 5 minutes because the interval does not contain 5 minutes. So excellent work right there. We get one mistake a day. That was our one mistake. So we have here, we'll go back, we'll do a cut in the video. Yay, cut in the video. So now we're going to do the serial question. That's what people were wondering about next, is how to do the serial question. Serial question is going to be one we use in Jump right here. Let's go take a look at it. Okay. So this question right here is comparing two cereals. And just think about this for a moment. So Roderick, like, what's your favorite cereal? What's your kid's favorite cereal? So like, if you just think about that, but the problem is my favorite cereal is Rice Krispie Treat cereal. I got the churro cereal. It's okay. It's, you know, Cinnamon Toast Crunch is one of the best. And like, that's just kind of like churros, like just cinnamon and I don't know, pastry. But when you think about children and adult cereal, like my parents eat like Fiber One. And I mean, come on, who wants to eat Fiber One? That's like something you eat as like a chore. Like you have to eat Fiber One. That's not something you want to eat as a cereal. So let's take a look at the children versus the adult cereal by copying it to the clipboard. You can automatically see the children's cereal, which is right here, has way more sugar in it compared to the adult. There's Fiber One right there with 4.1 grams of sugar. Here's like Lucky Charms. Here's Captain Crunch with all that beautiful sugar. There's actually Fiber One, or that's just horrible cereals. But then you go over here and you've got like Rice Krispie Treat cereal, Trix, Fruity Pebbles. I mean, just glorious cereal. Let's copy it. So I just copied it with Control or Command C. And then going over here to Jump, we're going to go into Jump. We can be anywhere in Jump. We can go up to the top and go to File, New, Data Table. So you want to go to File, New, Data Table in Jump. So you'll go to a new data table. And in the new data table, we need to edit, paste with column names. So you're in a new data table with File, New Data Table, and then go to Edit, Paste with Column Names. When you paste with column names, you'll see the column names appear up here. Now make sure you paste it with column names. This is what it looks like if you do it incorrectly. This is the wrong way. If you do this, start over with a new sheet and paste with column names. This is the correct way where they're blue and there's column names up here. Here is the wrong way where they're red, meaning categorical, and the column names are right here. Don't even try to fix it. Just new data sheet, paste with column names, and it's fixed. There's a quick way of doing it, Control-Shift-V. That's what I'm doing right there really quickly, but make sure you go to, just so you can see again, this is usually the big mistake, edit, paste with column names. I'm using that quick shortcut right there when I do it, but make sure you paste with column names. Don't try to fix it. New data sheet, paste with column names. So now that we have that out of the way, it's one of the big errors I often see when people do this problem is that they don't have it as quantitative variables. We can now do another step. There's another step for this problem, unfortunately, because we don't have the data properly created to analyze it. We need to go here to Tables, and then we're going to go to Stack. So we're going to go to Tables and Stack. That's going to take the two columns and stack them onto each other. So we get one column of data with the name of the cereal, the brand type of the cereal in the next column. So with Tables Stack, we're just going to double click both of these. Double clicking both of these means they're going to get stacked on top of each other. Let's go ahead and take a look at that. And here they are stacked. You can see the label of the cereal. And so I like, it's called label, but it makes sense. It's the label of the cereal. This is labeled an adult cereal. This is labeled a kid cereal. So here's the amount of sugar it has. And if you sort this, which you don't have to do, but we can, and let's sort it in ascending order. They've got blanks right here. I don't like that. Let's delete these. I don't think that'll cause issues. There we go. And you can see the children's cereal has way more sugar in it. They really created a problem where there's way more sugar in the children's cereal and there's way less sugar in the adult cereal. So there's Fiber One. I knew it was in here. Let's go now that we have it stacked to analyze fit y by x. And this is how we compare two means. To compare two means, we're going to go to analyze fit y by x. The x variable needs to be categorical. So that's going to create categories down here to explain the data, which is quantitative, so the y variable. And all we're doing right here is just looking at the two means, just like your visualization assignment. You can see here the children's cereal has a much higher average, or so you can tell by thinking about where these would average to, than the adult cereal. To run the test, we're just going to go here to t-test, which will then provide for us the t-test to compare the two means. So now that we have the t-test, you can see the difference between children's and adult cereal. The difference here is 35. But which of these has more sugar, the first or the second? The mean is positive. So would it, someone in the chat type 1 or 2? I've talked a lot so far. Would it be the first one is a higher mean? And you can see the answer right here. Or the second one is a higher mean? Because the difference is positive. And then what does this mean down here? I am 95% confident that the true difference between children's and adult cereals sugar content, like the true mean difference, is contained in the interval 31 to 40. But then what does that mean for this right here? Since the difference is positive, we'd be saying we're pretty confident, like I'm 95% confident that the difference between the sugar content of these cereals is contained in the interval 31 grams to 40 grams, where which cereal has more sugar. You can look at this right here to see it. And just like our assignment, we could do additional things, but which one of these has more sugar, it looks like? Children's or adults? This is the first group. And that relates to this one. We're taking the mean of this group minus the mean of this group. So it definitely looks to me like children's has more sugar than adults. And this confidence interval shows evidence that there is a difference because 0 is not contained. I think children's cereal has way more sugar content on average than adults cereal. And that is very, very, very statistically significant. 0 is not contained in that interval. We would reject 0 as an idea, and we would say an evidence of a difference right here. So let's go ahead and take a look. This is a 95% confidence interval, and let's go take those results again. So we have 31.24, and that rounds to 31.25, rounds up. And we have 40.36. And let's go right here. Yes. So right here, we are 95% confident. This is a good interpretation. Based on these samples with 95% confidence, children's cereals average between this much, so 31.25 to 40.36. It's a pretty good interpretation. You could basically use this for your project or for your visualization. Based on these samples with 95% confidence, you could talk about the difference between this. We would suggest that it could be this to this. But your interval would go through the 0, which means there might not be a difference. I think a lot of them do when you run the results. And we got it right. And that's got it. We're one question away from completing this. Let's hop back here to the main screen. So we'll do the final question right here on the homework. Get the homework for chapter 17 completed. What? How's everyone doing today? How's everyone in the chat doing? So say hey if you want while we get the next assignment up right here. We did that one. Margin of error. Oh, we got this. We got this. It's just margin of error. Let's do it. So this one right here gives you a confidence interval for how people are doing on a test. And these are the test scores, I believe. So the test scores for students. Are we going to get to see Bunny? Oh, I should. Yeah. Well, you've seen him with the bun thing, right? I should, I could take a video or something of him. I should like send myself pictures Chelsea sent me of him. I should do that. Roderick, remind me, send me a quick email or Discord message and say, send yourself those pictures. And then I'll like post a picture of Bun on here. We have he's got like a really cool Regal one where he's like, it was an Easter picture. But he should come to class today. I was talking to him this morning. I was like, Bun. And he was like, he nibbles at his cage when he just does that. Like, you know, it's a very large cage. He's in his cage is like, it's one of those like, animal pins you have that are like really wide. Like I could lay down in his cage. He's got a bunch of enrichment stuff in there too, but if I were to maybe push them aside a little bit, I could like lay down in his cage. And then he's got the area outside of his cage, which is kind of like fenced off, so he can't like go to the carpet because we have a really flat carpet because bunnies will eat carpet. They'll just like he's found an area we'll hear like a ripping noise and we'll go over and he'll have like pushed his carpet aside and he'll found a little tiny area to get at. And we'll be like, no, Bun. He'll run around real quick because he kind of knows when we're like, we'll be like, no, Bunny, don't do that. But he has a lot of enrichment things to like play with and bite at, and he's got like a cat playhouse thing, and he has a bunch of fun. But you have to watch out that he's not like biting the wall or finds something and like pulls the carpet to the side. Like the very flat carpet is so flat he never rips at that, which is good because you don't want him to get like an impaction in his stomach. But I watched a bunch of bun care videos. Chelsea helped me a lot with that, like watching some bun care videos to make sure we keep good care of him and he doesn't do bad things. So this is the interval right here. And we're looking at two different teaching methods. I'm gonna restart this question. Mail murder put this guy today. Let's talk about this question right here. Thank you so much. I want Bun to come to class too. I rarely, let me just say this real quickly. I rarely ever pick up Bun. I've picked up Bun twice. The first time I tried to pick up Bun, it didn't go so well. He kind of freaked out a little bit because you don't pick up bunnies a lot. At least our bunny, he doesn't like to be picked up. A lot of bunnies you have to be very careful. They can break their backs. They'll kick and stuff, and they can kick really strong. If you were to like hold them tight, that'd be very bad. So you pick them up like this, and they just have their legs free so that they can maneuver if need be. And the second time I picked him up, we had to. I think it was because he was his cage. He had maneuvered his carpet so that he could get to the real carpet below the carpet. Like we got the flat carpet and then the other carpet, and he had maneuvered the carpet enough over time. So we had to go in and totally remove around the carpet, like flatten everything out and get everything so he wouldn't go at it. And so Chelsea said, do you want to put him back in the cage? Because, I really don't pick up Bun much, and I should at least know if we need to pick him up, how to pick him up. And I said, yeah, I'll give it a shot. And I did. I was like, goodbye, I pick him up. And he was just kind of like, okay. And I brought him down, and he went down, and he was very happy. And it was really meant a lot to me that we did that. Like he was okay with it. He was chill. He's like, I trust you enough these days. You give me enough of my Bun food. But he's really nice. He's such a good bunny. Oh, let's start with this question right here. Are you ready? I'll miss Bunny. He's out there in the main room just hanging out. Let's do this. So here we are. We're talking about a confidence interval right here. We're talking about two different teaching methods, and we have the traditional versus the non-traditional method. And notice immediately when we're comparing these two means, like you have a bunch of students take this, 318 students, and the mean we're trying to estimate here from the sample mean is going to be the difference that we're calculating this interval. So this is from a sample of 318 students, and we're trying to figure out if there really is a difference between these two means. We estimate that the difference is somewhere between 5.198 to 11.002. So because this interval is positive, which teaching method is better? Good to see your hands, Lee. And so which teaching method is better? The teaching method that looks to be better right now would have to be the first teaching method. And let's kind of explain why. Well, when you see this interval right here, it's trying to estimate the truth between the two teaching methods. This scenario would look something like this. It would look something like 87 for the non-traditional and a mean of 80 because this interval is completely what? If you look at this interval, it's completely what? So the mean might be plausible for the non-traditional to be 87. And I'm just making up numbers. You might say, where do these numbers come from? I'm just making them up. So why right here did Brian give the first number a bigger mean? Because the interval is completely positive. Looking at this interval right here, the truth for the means, or the difference between the means, is somewhere between 5.198 to 11.002. And usually people get stuck. They say, well, how can I then find the margin of error for this interval? To find the margin of error for this interval, the margin of error is always half the length of the interval. So the margin of error is just half the length of the interval. If we go to the interval, and it goes from 5.198 to 11.002, all we're trying to do here is just get half the length of this. This is the margin of error. So let's just take half the length of the interval. So the length of the interval can be found by going 11.002 minus 5.198, and that's the length of the interval. The length of that interval right here is 5.804. Half the length of that is that, 2.902. So that's half the length of the interval, as in we would just go up and down this amount from the center. Now, we didn't calculate the center of the interval. It's about 8. It's 8.1 or something. You can find the center of the interval by going lower plus this. So what was the difference they saw in the sample? That would be a really good question, especially for a test. 8.1. The difference they saw in the sample was 8.1. If you go 8.1 plus the margin of error, you get that. And if you go 8.1 minus the margin of error, you get this right here. So this is very good to know that you can find the center of the interval by taking the margin of error and adding it or subtracting it from the lower and the upper. There's the upper of the interval. If you were to subtract the margin of error, you would be here at the center. And if you subtract another margin of error from it, you would then go down to this right here. So just seeing how that works, you can take and add the margin of error, and now you're back here. And the margin of error was half the length of the interval. So really good to understand this is the margin of error, which is half the length of the full interval. So now that we've got this, let's copy it. Let's bring it over to here. Margin of error understood and talked about. Good stuff. If a 98% confidence interval was calculated, the margin of error would be what? So you have to think how it works. 68, 95, 99.7. Just with your hands right here, you're saying the answer to the question. If you go from 95 to 99.7, you go through 98. So 95, you're welcome, Hannah. Awesome work. Yep, you should have this done. Feel free to swing by and check out the video later. This is going to be a wider interval as the critical value would increase and the margin of error would increase as the critical value increases. So everything is increasing right there. And what does this mean? Well, with 95% confidence, a non-traditional student, is expected to score between this many to this many points higher than a student in a traditional. I think that's got it. With 95% confidence, non-traditional. Let me see here. Oh, I think I know what it is. Oh, I think this is it. Because this says student. I got tricked. Students. Okay, so the difference right here, and let me explain. This one is talking about an individual student. This is talking about the mean. I was like, something looks different. I almost got tricked by my Pearson. So this one is talking about the mean. This is talking about individual students. So we're talking about the mean. We're confident that there's difference in the means, not individual students. And it's the non-traditional is higher because the first number here is positive or the whole interval is positive, and this is the non-traditional mean. So understanding that is pretty important. Does this result suggest that students who learn with non-traditional will have significantly higher? No. Oh, yes. Well, on average, does it say on average? Higher means. Okay, good. It says higher means, not an individual student. If it says individual students will have higher, I'd be like, doesn't talk about individual students, but it is talking about the mean. And it does suggest there's evidence that there is a difference here because 0 is not contained. The interval is entirely above 0. There is strong evidence of a difference right here. So there is strong evidence of a difference because this interval does not contain 0. We're saying we think that on average, students in the non-traditional math setting would get between about 5.189 points to 11.002 points higher. And that's got it. That's the question right there. Yes. Okay, what other questions do we have? If you have questions, let me know. Let's see. What other questions do we have? Let me load up. I think we haven't done any of the quiz today. Who all is here? Feel free to say hey. I think the night after an assignment, everyone's really tired. I'm really tired too. We just had 320 and 201 assignments due last night. And so I think everyone's like, oh, I'm beat, Brian. It is. We do some, let's see right here. I'm looking over the quiz to see if there's any like major ones where I'm like, oh, people get totally stuck on this one. There's repeat questions that you get. And so here we got some, here we go. Let's see. I need to see the bunny, says Lenny. I wish I could just, I don't know if anyone else here has bunnies. I wish I could just pick him up and bring him here and be like, here's the bunny. And just be like, check out the bunny. And he'd be freaking out if I did that. Because he's not used to getting picked up. He's like a Cadbury bunny. So he's probably weighs like 15 pounds. He's not like really heavy, but it's interesting. Bunnies are not a huge fan of being picked up. They're kind of like cats. Like a lot of cats would probably not want you picking them up. And, some cats would like that.